Okay, so we've gone through the to-do list so that you know what order to start simplifying. And now we need to talk about how you write your final simplified expression. Okay, remember, we're not necessarily looking for what the variables equal. There won't be an answer like a final number. In these cases, our answer, we know we got to the answer when there is nothing left to do. There are no numbers to add together, nothing to multiply. We are physically out of things to do. So once we're out of things to do, how do we write our answer? And the way we do that is some mathematical etiquette, some things that are expected of a math student to do to show proper final answers. First thing we do is order the terms so the degree decreases from left to right. So if you've got exponents, looking left to right, they'll go largest to smallest. So for example, x squared plus x. Squared is a 2. If I don't see an exponent, there's really a 1 there. And so you can see alphabetical order. If I had 3x to the third power, it would go third power, second power, first power. So that's what we mean by order decreasing left to right. Next, the constant will always be last. So if you have a term that has no variable, that is always going to go to the end. Variables always have preferential seating, I guess, when it comes to the order of your simplified expression. That's why you'll see x plus 3. My constant's always at the end. I guess I'll add these back just in case you want an example. And finally, what happens when you have more than one variable? X's, Y's, Z's. We know that any powers go in order of largest to smallest. Variables go in alphabetical order. So it would look something like this. If you had some a to the third power and b's to the third power, plus 4a plus 7. So here's an example of an expression where we've got variables in alphabetical order. So the a and b each have a power of 3. So they're up front because it's the highest exponent. But even though they both have a power of 3, a comes before b in the alphabet. So a gets first in line, b is second. Then from here, I have just plain old 4a. A comes after b, but the exponent of the a is a 1. 1 comes after 3. So it's kind of like a stair-step type situation. You take all of your highest exponents and then order in alphabetical order. Then the next highest exponent, alphabetical order. So let's just get into some examples. Now, one thing you do need to know is that while we work through these examples, there's actually a very specific way that you're going to show your work. So copy down your first example. And we're going to draw a little chart. We're going to do something called a proof. It's something that you'll do in geometry. Basically, you'll be defending each step of your work. What property allowed you to do that step? A couple things that will come in handy with this. When you get to geometry, life will be easier. But also, it helps ingrain the properties in your brain. It's going to help you be able to justify. If you get something wrong, you can go back and look and say, you said you did the commutative property, but did you really? Or if you can't explain what you did, maybe you shouldn't do it. So it's a really good way to kind of check yourself along the way. If you can't explain what you did, you either don't understand or maybe you need to double check what you did. So what I need you to do is look at the to-do list. So go find your to-do list and we're going to go through the steps. So the first step, do we have grouping symbols? I have no grouping symbols anywhere. Do we need to complete the additive inverse, changing subtraction to addition? And actually, I think that's actually the first step, is taking any subtraction, turning it into addition. We have no subtraction. We're good there. Now we're going to use the commutative property. So the grouping symbols, we'll be looking at that with the distributive property. So sorry about that. So the first thing is additive inverse. Do we have to change any subtraction to addition? No. Commutative property, that's the second step, is to commute so that our like terms are together. One thing that's really helpful for a lot of students when they look and say, I don't know what to put together, is to either color code or use shapes. So maybe I always circle my X's in red, and I circle my constants in green, or I put a square around my constant. Okay. So when I get to the commutative property, I'm now going to take what I circled, my X's, and I'm just going to copy them down together. Now, if you have different colored pencils, this actually could come in really handy for you. So all I did was I used the commutative property to rearrange so that my X's are together right here and my constants are together right here. Remember, the order is important. My constants always go at the end. That's why when I rearranged, I put the X's up front and the constants at the back. So on the right-hand side, what I'm going to write is commutative property of addition. During these examples, definitely write everything out here. I ran out of room. Definitely write commutative out. After you get the hang of it and you've been successful over and over, then we can start talking about abbreviations. But for right now, write the word commutative out. Everybody needs to practice learning that word anyway. So the next step is to combine like terms. So that's step 3. Step 3 is combine like terms. Now I can look at this and say, okay, I have an X and I have 5 more. Now, the one thing that some people struggle a little bit with is I see a 5, but I don't have a number here to add to 5. If you think logically about what's happening, I have an X here, a single X, and 5 X's. Together, that gives me 6 X's. If you don't see that, you can always write the coefficient as a 1 if you don't see a coefficient. So if it would help you to write a 1 in front of that X and make it the coefficient so that you can see that our answer is 6, do it. Some of you will not have to. 2 plus 7 is 9. And what I did was combine like terms. There's nothing left to do. Once I've combined like terms, everything's in the correct order. If you didn't have this in the right order and you had to rearrange to get it in the right order, you would have to write commutative property again. But if we do, the first time we do the commutative property, if we pay attention to the order, we won't have to do it again. Again, this seems like a lot of work, but while things are easy, it's good to get a habit. Example 2. Copy down the expression. So draw ourselves a little table or a T-chart, some people would call it. And the very first step is to look and see if there is any subtraction. Subtraction needs to become addition. Remember, we are combining like terms. We're not subtracting like terms. We're combining, which means addition. The commutative property does not work with subtraction. You need addition to commute. I'm not moving anything around while there's subtraction because I'm going to start getting myself into trouble because I'm not looking at the numbers correctly. Okay, so it's very important before we start a thing, we deal with any subtraction. So, a couple reminders. Add the opposite is one way that you can remind yourself how to complete the additive inverse. That's technically what we're doing, is the additive inverse. You can think of it as same, opposite, opposite, or add the opposite. Either way. Doesn't matter what happens, but there's nothing wrong with 2a. The problem comes in with this subtraction. I don't want subtraction. I want addition. However, I can't just go around changing operations. I can't say, I don't like subtraction, making it addition, deal with it. Doesn't work that way. I now changed the problem from taking away 10, and now I'm going to add 10. Does not work that way. So, for every action, there's an opposite reaction. Just like science, right? My action is changing subtraction to addition. So my reaction, which becomes an opposite reaction, means this 10 right here becomes negative 10. Let me change my arrow here. So subtraction became addition. Positive 10 becomes negative 10. Additive inverse, a number plus its opposite equals 0. So by me taking that number and making it the opposite, after taking subtraction and making it the opposite, everything stays equal, okay? Now, if I have addition, don't mess with it. Addition is good. If you have addition, you don't do anything with it. There's nothing wrong with 3a, but I do have a problem here. My subtraction has to become addition, and my 12c becomes negative 12c. Please draw these arrows so that you can see what's happening. Use a different color if you have it. It'll be helpful for you to see what's happening for each of these. And to be quite honest, when you think about what's happening here, if I'm subtracting a 10, that means I'm losing 10. If I add a negative 10 means I'm losing 10. So we are not changing the value, we are just changing the way this looks so that we can manipulate our expression. It's all about manipulation. We've got to do certain things to make this expression set up where we can do the work we need to do. So we're going to call this additive inverse. And we can abbreviate part of that. So the next thing we're going to do is take a look at and see what my like terms are. Now, usually if there are an operation and a negative next to each other, you'll see parentheses. Those do not count as grouping symbols. That's just separating the operation from the integer. So now I'll go through and I'm just going to look for all of my A's and I'll put a box around my A's. Then I've got a constant here. I don't have any variables, so I'll circle my constant. And then I've got a C, so I'm going to draw a triangle around my C. Now this would be a case where if you didn't want to color code, you would just draw different shapes. So maybe you would rather stick with the same color and just do different shapes so that you can visually see the different things happening in your expression. So once I identify my like terms, I'm going to rewrite them using the commutative property so that my A's are together. Then I'll write my C, my negative 12C. Remember, alphabetical order. And then I'll finally write my constant. Combine like terms. Nope, that's not correct. We commuted. Sorry. Commutative property of addition. So now finally, I have A's that I will combine. If I have 2 and 3 more, that gives me 5 A's. Plus negative 12C plus negative 10. That's combined like terms. Now there is one last little issue with my plus negative 12C and plus negative 10, but we'll come back to that. Right now, this answer is good. Let's take a look at another example. So get example 3 copied. Let's draw our little T-chart. Step number 1, look for any subtraction that we've got. Complete the additive inverse. Now, some of you will have more success or feel more comfortable actually writing your properties first and then showing the work. So maybe as you're looking at this, you're saying, okay, well, there is some subtraction, so I would do the additive inverse. So let's do this example, writing the property first, then the work. So I see the first thing I have to do is complete the additive inverse. So with the additive inverse, this only affects subtraction. So maybe you want to go through and deal with that first. 2x squared becomes negative 2x squared. This is fine, this is fine. Here's another subtraction that I have to handle. And then 9w becomes negative 9w. And other than that, everything stays the same. You are only changing what we have a problem with. There's nothing wrong with the rest of this. The only issues were in these 2 spots. Remember, addition is what we want. The minute you have addition, we're happy. We're good. So the next thing we'll do is we want to identify our like terms. So I've got W's here. I like color coding. I have x squareds here. And I've got a constant here. And I have x's here. So I have a lot of different things happening. But once I've identified my like terms, I look at my to-do list. So after changing subtraction to addition, I'm going to commute to get my like terms together. So my next step is commutative. Property of addition. Now remember, when we commute, we want everything in alphabetical and exponent order. So because I have an exponent of 2, that gets to go first. So negative 2x squared comes first. Now I don't have anything else with an exponent other than 1. So now I have my w's and my x's. So alphabetically, W comes first. So I have negative 8W plus negative 9W. Then I've got my 3x, and then my 7. Now, if you get big, long problems, you definitely want to double check how many terms you have. I've got 1, 2, 3, 4, 5 terms. 1, 2, 3, 4, 5 terms. So I didn't leave any out. That's one thing that you have to be very careful of. Don't leave any terms out. So my final step is going to be to combine like terms. I don't have anything like my x squared, so my negative 2x squared stays that way. For my w's, I have negative 8 plus negative 9. This is where if you're struggling with your integers, it's going to get you. So let's think about this. If I have 8 negative w's and I combine it with 9 negative w's, together I have 17 negative w's. That's a parenthesis. I only have a 3x and a 7. Nothing crazy there. Now for example 4, it's a little long. I want you to copy this down, start your chart, and I want you to pause and try this on your own. Now I know this just got started, so if you want to try the first step, pause, try the first step, check the first step. If you're good, pause. Try step 2 on your own, check step 2, pause, and so on. Or go for it and try the whole thing all on your own right now. If you're really nervous, just do the whole thing with me. So step 1 is additive inverse. So this is where we're looking for any subtraction. Addition is okay. There's my subtraction, becomes addition. 3y becomes negative 3y. Addition, addition, addition. We're good. So now I can just copy down the rest of my expression. Now I can start identifying my like terms. So I usually just start at the beginning, identify that term, and then go see if I can find others like it. So x to the third. Boom. Right here. X's. No other x's. Y's. Got a y here, and all I have left are x squareds. So my next step is going to be to commute. I need to commute my terms around so that everything that's alike is together. So now remember, alphabetically, we go in alphabetical order by exponents. So I have x to the third power. I don't have any other third powers, so I know that's going to the front. So that one's done, that one's done. I don't have any more third powers. So now I look for second powers. Anything to the second power. Oh, look at this, 7x squared. Now I'm crossing these off as I go because this is kind of a long one. You don't have to do that. So my second power is done. Now I look for my terms with a variable to the power of 1. I have x's and I have y's. Alphabetically, x's come first. So 5x goes first. And then finally my y's. Then finally, I combine my like terms. Oops. And that's it. Hopefully you're feeling a little more comfortable with simplifying expressions.